Hi, in this video I'm going to talk about geometry generators, which are one of the more exciting renderers in QGIS. Very groundbreaking. It's a sub-renderer. It was added several years ago at QGIS version 2.14. And with it, you can use the expression engine to modify the geometries or even create new geometries just while rendering data. So the data on disk is not edited or changed. You're just changing the way it's appearing on the map. So the exciting thing is that the resulting geometry does not have to match with the original geometry type. So down here at the bottom, we have the symbol layer type menus. So for points, we have all these symbol layer types available, and you see geometry generator is one of those. These are the symbol layer types for lines, and it's there as well, and with polygons. So let's get out of this PowerPoint and into QGIS and see how this works. So here I have QGIS open, and I have this municipalities layer loaded. And this is a different version of the layer than the one we used with the topological coloring. This one is in the geometry generators folder, and the difference is that it hasn't been dissolved by municipality. So it has, instead of 99 polygons, it has 1,500. So every island is its own feature. So it's not a multi-feature data set, and this will work better to show how this works. So first I'm going to change the symbology of this to give it a black background and white outline. So the fill color is going to be black and the stroke color white. And then I'm going to duplicate this so we have a working copy of this layer that we can use and compare what we do with the geometry generator to the original copy. So I have municipalities copy, and I'm going to select the simple fill symbol layer type, and I'm going to change that to geometry generator. So you'll see down here you have this geometry variable, and this is the geometry of every feature in your data set. And then you have the geometry type, and you can choose polygon, line string, or point. So we can transmute this to different things based on an expression. So I'm going to choose point, and temporarily we'll get basically what amounts to an outline marker along the border of every polygon. But I'm going to click the expression button to open up the expression engine. And when we're working with geometry generators, you're typically working with the geometric functions. So in the geometry section, you can see that there's quite a few functions in here for manipulating geometries in QGIS. And we're going to look for the centroid function. So you can see the centroid function just needs the geometry as input. So we have our geometry here. So I can put my cursor just before the $sign and double click on centroid to put this function into the expression engine. It shows a little red triangle indicating that our expression is not complete. There's a character missing. So I'll enter the closing parenthesis, and now we have a valid expression. And you'll see that the output preview is a geometry point. So I'll click OK. And now we're going to get the centroid of each polygon. Now the thing with centroids, if we go to an odd-shaped polygon here, the centroid actually falls outside the polygon. This point up here is actually the centroid of another very small island off the coast there. So, but this centroid is relating to this, and the centroid actually falls outside of it. So that can happen. So let's look at another function. I can open up the expression engine again, and there's a different function called pole of inaccessibility. So I'll expand geometry, go down to the P's, and I see pole of inaccessibility. So this takes a geometry and a tolerance. So I'm going to replace my centroid function with pole of inaccessibility, and I'm going to enter a comma after geometry and a value of 1 for the tolerance. So I have a valid expression, and I'm getting this point geometry. So this is, well, this function calculates the approximate pole of inaccessibility for a surface, which is the most distant internal point from the boundary of the surface. So this will give us a point that falls within every single polygon and will really be the center of that polygon, or as far as you can get from the edge. So I'll click OK, and you can see the point moves to the center of that island. So let me go ahead and make another copy of municipalities, and I'll drag this one up above. And now what I'm going to do is try a different function. I'm going to again choose geometry generator, and I'm going to keep the geometry type at polygon this time, and I will click the expression button, and we're going to try a buffer. So you can see buffer is another function in here. So I'll double click on buffer to put it in my expression. And the buffer tool just requires a distance. There are other options you can include with it, but minimally you just need a distance. So if I include a negative distance, it will give me an internal buffer. So I'll put in a negative 2,000 for a negative internal buffer of 2 kilometers. And I'll close the parenthesis, and I'm getting a geometry polygon as my output preview. So I will click OK, and I'm going to change the fill of this to something easier to see. So we'll make it like a bright blue. And you can see now we have an internal buffer of 2 kilometers from the edge of each polygon. This one takes a little longer to compute if we zoom out to the full extent of Denmark. But it's another use case for transmuting the geometry of the data and how it's rendered. So sometimes we can use these to much more quickly create an effect without having to process the data, really. So these are two very simple examples just to show you how this renderer works. And what I want to do now is go back into the PowerPoint to give you some more examples that you can experiment with. So I'm back in my PowerPoint presentation, and I have a slide here from Scott Reinhard, who works for the New York Times, and on May 17th of 2020, he tweeted this out. He said, "I made these arrows solely with QGIS functionality. 3 cheers for the geometry generator," from the New York Times, where New Yorkers moved to escape coronavirus. So in this example, he had 2 sets of points where people used to live and where people are living now after Corona. So where they moved to. Two sets of locations for each person. And he basically created a line between a person's previous and current address and symbolized it with an arrow to show that. And in fact, he actually may have used polygons, and he had styled these by the magnitude, the number of people. So bigger arrows for more people. So this was, a little bit more involved than what we just did, but still a fantastic visualization that can be created simply with 2 sets of points and a geometry generator expression. This gentleman, Michael Stutz, has a GitLab repository where he has different geometry generator examples, and you can download the style for each one of those and apply it to your data. So with some of these, there's some are cartographic, some are more technical, and some are just silly and fun. Points as buildings in this case. And some of these you may have to adjust the expression based on your coordinate reference system. So, because the distances are involved in the expression sometimes. But these are some really interesting examples, and he has quite a few of them in here. So again, you've been introduced to it now. And so now I want to just kind of let you go explore some of these examples when you have a chance and see what can be done with them, and think about how you might apply these to some of your data. This first one with angles and distances on the edges of parcel boundaries is super practical. Johannes Kroger is another data visualization expert, and he has a blog called Hans Enjoys It, and he has a couple examples of geometry generators. One is this Joy Division map. So Joy Division was a classic punk album from the 80s with an interesting album cover. And so people often like to try to recreate this based on terrain in their area. So he has been able to duplicate this effect using geometry generators with points against an elevation surface. And he has that set up so it's fairly easy to download it and apply it to your own data. And similarly, the Lego rendering of elevation data, you can also do with geometry generators. So those are kind of fun. And then Topi Chukhanov has another GitHub repo with more examples. Some of these are very artistic. The Klimt is rendering that mimics a Gustav Klimt fine art rendering of polygons. He has this pencillist style that gives an antique or hand-drawn pencil effect to polygons. So if you're ever looking for a more hand-drawn look to a map, you could try that style and modify it. And then Digital Rain, which is kind of a modern sci-fi kind of rendering, and kind of gives you an example of what can be done with this renderer in combination with other renderers. So I'm going to leave this with you, and you can explore these examples, see what can be done, and see if you can come up with ways to apply them to your own data.